Question 4. So now below are the graphs of f of x and g of x. So in this first bullet point, we are told that f has a turning point at c and passes through the x-axis at 1 and 0, right? So it has a turning point here. This is the turning point of f, right? And passes through this intercept here, right? And then D is the y-intercept of both f and g, so this is D. The graph of f and g also intersect each other at E, so both graphs intersect each other here at point E, and at J, so they also intersect each other at this point here. So the vertical asymptote of G passes through the x-intercept of F, right? So this the intercepts, right? And then the asymptotes are passing through here. So let me just indicate. So these different color. So the asymptotes, we are told that they are passing through here, right? So this is the horizontal asymptote. Now what we have here is 4.1. we are told to write down the value of P. Let's see what they're looking for. So the value of P is basically this one here, right? So we are given so that's basically the vertical asymptote, right? But P is not it's just the value on its own. So this is the vertical asymptote. We are given the vertical asymptote to be equals to 1, right? We know x plus P is equals to 0, and we know that the vertical asymptote is equals to 1. So if you take this 1 to the other side, we have x v minus 1 is equals to 0. So the P value is actually minus 1. So this is the value of P, right? As I said, this is the vertical asymptote, x equals to 1. As you can see here, it goes all the way up, right? And this hyperbola here, it doesn't touch the asymptote, right? As you can see here. Fine, so now we're done finding the value of P, which is equals to minus 1. Then 4.2, we are asked to show that A is equals to 3 and B is equals to 2. So for us to show that this value of A and this value of B here, for us to do that, we need to go to our graph, and because we're having f of x being equals to what? X squared. So it's x squared plus bx and then minus 3, right? So minus 3. So for us to find this b, we can use because this is f, right? F of x, this one here. If we use this point here, which is 1 and 0, it means now that here it's going to be 0 and then at x is going to be 1. So you're just going to substitute 0 here, and then here it's going to be 1 squared plus b into 1 minus 3, right? As I said, we're using this y-intercept. So it's going to be 0 is equals to 1 plus b minus 3. So it's going to be 0 is equals to b minus 2. So transpose the 2 to the other side. We have b is equals to 2. So we have proven that b is equals to 2. So now we have to prove that a is equals to 3. So for us to do that, we having our equation of g here, right, which is g of x is equals to a value over x plus p. So it's a value over x plus p. remember we said p is equals to -1. P is equals to -1, so g of x is equals to a over x minus 1, right? And to find the value of a, we can use any available point here. What is it? If we try point D, because that's the y-intercept, so this point D here, I'm just going to indicate with this blue, this point D here, try point D, which the coordinates of point D are, we know that the y value is -3, right? So it's -3 and x is 0, so it's -3. So you're just going to substitute in this equation. So you're going to say my g of x is equals to a over x minus 1, and we substitute our d, which is 0 and -3. So it's going to be -3 is equals to a over 0 minus 1, which is equals to -3 is equals to a over -1, cross multiply. My a is equals to 3. So that's how we found a being equals to 3. So yeah, we're done with 4.2. Now we're going to do another question, which is 4.3. So now that we've done 4.3, we are asked to calculate the coordinates of C. So what are the coordinates of C? What is C in the graph? So let me remove some of the info so that we can see what is C. C from the graph, let me first look. We were told that F has a turning point at C, so C is actually the turning point. Here it's supposed to be C, right? And we have already identified the equation of F, right? F of x is equals to x squared plus bx minus what? -3, right? -3, and we have proven in the previous question that b is equals to 2, so f of x is equals to x squared plus 2x minus 3, right? And then now to find the coordinates of C, which is the turning point of F, we're going to say x equals to minus b over 2a is equals to minus 2 over 2 into 1, right? Equals to -1. So this is the x value of the turning point, which is -1. And then to find the y value, we substitute into f of x, right, plus 2 into -1 minus 3. It will give us -4, right? So therefore my C, which is my turning point, is gonna have coordinates of -1 and -4. So these are the coordinates of C. Now we're done with these coordinates of C. We're going to write down the range. 4.4 wants us to write down the range of F. So C, remember it's -1, -4. So these are the turning points, right? TP. And to find the range, you say y is greater or equals to this y value of your turning point, which in this case is -4. So that's how you're going to write down your range, right? So range is actually the y value, so you're predicting the y value. So if you were to write the turning point here, you're predicting the movement of y value. So this y is equals to -4 is the lowest value of y of the graph of F. So it starts from that lowest value of y of -4 all the way up. There's no other value that is less than -4 in the graph of F. Hence we choose this as our final answer for the range. And then we go to 4.5, where they say determine the equation of the line through C that passes at an angle of 45 degrees with the positive x-axis, right? So what are they saying here? So let me first erase we are told that I must determine the equation of the line through C that creates an angle of 45 degrees with the x-axis. So what it means is we're having this line that passes through C, right? It goes something like this, something like this. So this line creates a 45 degrees here, and it passes through this point C. So we want to identify the equation of this line. We know that since it's a line, it's going to be y is equals to mx plus c, right? But because it's 45 degrees, you can say tan of 45 degrees equals to the mass, of which tan of 45 degrees is equals to 1. So the mass is equals to 1, right? So you have y is equals to x plus c now, right? So for us to find the value of c, we need to substitute point C, because that's where the straight line passes through. Substitute point C of -1 and -4. We will say where there's y, put -4 is equals to where there's x, put -1 plus c. Therefore c is equals to, transpose the -1 to the other side, we have +1, so it's -3, right? So the equation of this line is going to be y is equals to x minus 3. So this is the equation of the line that passes through C. And then now that we're done with that, what we're going to do now is in 4.6, is the straight line determined in 4.5 a tangent to f? Explain your answer. So 4.6, is it a tangent? Well, it depends, right? So for it to be a tangent, it must pass through point C only, right? Let's say you have a parabola like this, and then it passes through just at one point, then it is a tangent. But because this line, if you see the way I drew it, it passes through this point of C, and it also passes through the point of D, right? So it just makes it not a tangent, because a tangent passes through a graph at one point. So the answer for 4.6, you say no, it's not a tangent to the graph. Why? Because it passes through point C and D, right? So that is the answer for this question here. And then 4.7, which says that the function of h of x is equals to f of x. It's supposed to be f of x minus, so here it's minus, so f of into my m minus x, right? And plus q has only one x-intercept at x is equals to 0. So this is equals to 0, x equals to 0. So here it's f of m minus x plus q. Determine the values of m and q. Okay, cool. So we're having this function of h of x, right? And we're told that it has only one x-intercept at x is equals to 0, right? So remember that our f of x is actually equals to x plus 1 squared minus 4, right? Remember, why am I saying that? Remember this equation here, and we knew that our c value, it's minus 1 and minus 4, right? So this would be the equation, right? This would be the equation of f of x, right? So now we can substitute. You can say h of x is equals to, so in f of x we're just gonna put m minus x. So we're just gonna say m minus x plus 1 squared minus 4. So I'm just literally putting this inside, but I'm putting this this m minus x here at x, hence we're having m minus x, and then there's 1, right? So the same goes with this minus 4. I just placed it here, which is the same as this one here, right? Cool. So this is what I'm having. What this means is this. So this would be plus q, right? So if I were to write it nicely, h of x is equals to into m minus x plus 1 squared minus 4 plus q, right? So to find the value of q, you can say minus 4 plus q is equals to 0, whereby q is equals to 4. So that is the solution for this one. And then to find this m here, you will say m minus x plus 1 is equals to 0, but you're told that the x-intercept is actually equals to 0, right? But x is equals to 0, so m minus into 0 plus 1 equals to 0. So therefore m is equals to minus 1. So you have found your value of q and your value of m for this question here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.